Hello there. This is an introduction video to VDM++, where we uses the Overture tool, which is an IDE to write VDM in. What this video will be about is how to create your first unit tests in VDM++. If you have never tried VDM or the Overture tool before, then I have linked an introduction video down in the description, where I'll show how to download and install Overture and how to get your first VDM++ program up and running in the Overture tool. But let's try to make our first unit tests. So the first thing we'll need is that we will need an project. You know, a project where our functionality is in, but also where we write our unit test in to test if the application we actually are making is doing the right thing. So we go to Files, we go to New, and we go to Project. Here we'll choose the VDM++ type because PP stands for plus+. We'll hit next, and we'll need to decide on a name for our application. In this case, let's call it the first unit test program, or just first unit test. We'll hit finish, and it will create our project. As you can see, it's empty for now. So the first thing we would like to do is that we would like to create a file. So we will right click it, we'll hit new, and we will like to create an empty VDM-PP file. You know, just to create a clean slate for us to start from. So we'll hit that one, and we will call it, let's say, we could call it main, or we could call it, let's say, animal or first unit test. Actually, it can be what we like. So in this case, we'll just call it for what our file is named. So first unit test. We'll hit enter, and it will create our file, our clean slate. But before we create our unit test, we would like to create the class that the unit test needs to prove is working. So we'll say class, as you know for other languages, and we'll give that class a name. Let's call it animal. In Overture, we have something called end, and that defines for the compiler that now this class have ended, and we need to call it end animal. So it's completely sure that it's animal. Then, underneath we have class second, end second, to have multiple classes in the same file. But for now, we'll just, have one, and then we'll see if we get multiple ones later. But in the class type, in classes with VDM++, there's different kind of things we can do. You know, in classes in C++, we have private and public and protected, and we can make member functions, and we can make functions, member variables, and we can make functions and such things. In here we have the different opportunities, the different possibilities. We have types, which is defined type in C++, where we can define custom types for this class. Then we have values, which is const values, const members that we can define. This could be, let's say, default values that we would like to have. Then we have instance variables, and that is the member variables from C++. Variables. Then we have functions, and functions is not functions as we know from C++. In here is yes, you can say that it's static functions. It's functions that can have no relation to the instance of that class, but if we provide it with the necessary information, then it can calculate things. What I'm trying to say is that it's a static function. And we have operations, which is functions as we know from C++. Okay, but our animal class in types, let's say we like an animal type. And in this case, let's say that our animal type is an integer. Let's say that it could also be a natural number. Natural number is a number that needs to be above 1, so it cannot be minus or comma numbers. But in this case, we'll just say that it's an integer. Then for that animal, we like a default value, and that is a good const value because it should not change. We don't really need that here. But we will just show it to show how to make these const values. So we will say default animal ID, and we'll define that as 10, let's say. Now we would like to make the instead variables, or the like class member variables, and we would like to make an animal. Let's call it animal ID. And that animal ID will be of the type animal T. And its default value should be default animal ID. There we go. And something is missing. There we go. Okay. And now let's say that we would like to make sure that our animal ID is always between -10, or let's say -50 and +50. Then what we can do is that we can say we'll like to make a variance, and that variance needs to determine whether the animal ID is between these values. So we will make a function called between values, and there we'll pass in the animal ID. And then, because between values always will get past the animal ID, so we can actually define it as a const function. So that will go into the const. And that is what we use like for checks. We use functions to check if things is done correctly. So we can say between values, and we'll say that that takes the animal type and it returns a boolean. So if this boolean is true, everything is okay. If this boolean is false, then the program will crash and it will tell you, hey, the type is, or the ID is not in between what we thought it would be. And we'll go here and we'll say between values, and we'll call this the ID. Let's call it that. And we'll say that, and here we'll say is ID above 50, and is ID above -50, or equal to -50, of course. And we'll ask, is ID below or equal to 50? And then what this will do is that it will say, is this true? Yes. Is this true? Yes. Then return true. If any of these is false, then it will return false, and the program will crash and it will tell us it is not in between anymore. Okay, let's get to the next one. So now we would like to make a constructor for our class, and that is done with, we will write public animal, and we will say that it will take an animal type as input variable, and what it will return is that it will return itself, and that is how it's done in the Overture or in VDM. And what we now will do is that we will say animal, give that type a name. So we will say animal type is actually an ID, and then we'll make these parentheses. And what these parentheses is that they are like VDM's curly brackets, as you know from C++. And here what we can say is that we can say that animal ID should be equal to the ID that we get from the user. And remember here, let's say that we actually edit this to like below -50. Then when we change this variable, this one will be called and we'll check, is ID actually valid? We don't need to make a valid check inside our constructor. Pretty smart. And this we can try to check later on if this actually happens. And now we'll try to make a public get method, so get ID. And this will take no argument, but it will return an animal type. And we'll say get ID, no arguments, and we'll make the weird curly brackets or parentheses again. And this will of course just return animal ID. There we go. And this actually needs to be public, so other people can see what animal type is. So now we actually have something that we can test. Now we have an animal class. So we'll make a bit of space here. We'll hit save, and we will make our class animal tests. And that should of subclass. And this is like the inheritance in VDM++. That here we write of subclass is subclass of is what it's called. But the problem is that we don't have our tests yet. like we don't have our test library. So how do we actually get our test library? If we say here, it will say us, but there's nothing called test case. And the way we get like the unit tests is that we right click on our project, we go into new, and we say add VDM library. And here we then can hit the VDM unit, which is our unit tests for VDM. And as you can see, the error have gone away. Okay, and now we define operations function that it uses, and we will define a default constructor again. So public animal tests, that will this time take a sequence of chars, and it will return itself, of course. And the reason why we have a sequence of chars is because we would like to give the test a name, or the tests like this suit a name. Because when we will write all our tests in our console, then it can be a bit hard to actually distinguish where have the different tests come from. But if like our name is printed above the tests, which is then afterwards written, then we will know, okay, these tests are for the animal case, let's say, for the animal class. And we will say animal, we have the name of the class, actually animal tests, of course, there, and we will make the curly brackets or the parentheses, and we'll say set name. And this set name comes from our test case. It's a function we have inherited from that one. Okay, now we will need to make our tests, like just one of our tests. So we'll say protected, and we will say test constructor. This is just a name, remember, but it needs to start on test. This is important. And we'll say that this gets nothing and it returns nothing. We say test constructor, remember no arguments, and we will make again these. Okay, now we need to set up our test. So what do we need? We need an animal. So we will say DCL, and this is a way inside of these curly brackets to define variables like objects. So we will say animal object, and that is of the type animal, and this should be a new animal. There we go. But we will need to give it an ID, and in this case we will give it, let's say, 15. And then afterwards we'll say assert true, and then we'll say animal object dot get ID, is that equal to 15. We'll save it, no error, it's perfect. What we could do to abstract it a bit more, we could say DCL, then we could say ID. That ID is of the animal type, and we define that as 15. And then we could just use ID here, and we could use ID here. Then if we would like to change our test, we could just change it here instead of both places in here. Okay, now we will need to make a new one, protected, run tests. That one will take nothing and it will return nothing. And this here is where all of our tests in this test case will actually be in. So we'll make the weird curly brackets again, our parentheses, and we'll say test constructor. Defined like this. Let's say we had one more test. Then we could just define that underneath. Let's say that was test below minimum, and then we tested, if it could handle the below minimum, which it cannot because we have defined the invariance here. Okay, but we don't have that yet, so we'll just keep one test for now. Okay, next one. So what we'll do now is that we will have one called the class tests, and this is like where our test will be run from. And here we'll have operations again, and we will have an execute. It will take nothing and it will return nothing. Execute. Oh, and we'll define that as public. Again, no arguments, and we'll make these ones once again. Okay, good for now. So what we now will define is that we will need to define the tests, like the test cases that we would like to run. And then on each of those test cases, you'll call the run tests, and that run test will call all of the tests in that test case. So what we'll say is that we will say let tests be a new, that will be a set of tests, and we'll make that set be a new animal tests. And then we will say that we have a test suite, and that test suite should of course be constructed. So test new test suite, and we'll have the test in here. 2 seconds. We need of course the constructor here, and we'll call it the animal test. And this was the name I told you about before. And then we have the result from the test which have been running, and we'll call that test result. And again, the test suite and the test result is coming from the test class, which we just imported with the library. And this will be new test results. And we'll say that we'll just indent this, I think. Something is wrong. We need a, no. I know what we need. We need this one. And we'll say n. And 2 seconds, we'll say ts.run our result, because then it will be saved in this. So this one will run all our tests, save like it in result, and then we can say IO. I'll scroll a bit down. IO print, and then we can say result to string. We will convert the result to a string, and there we have it. This should actually do it. Oh, I know what we need. Of course, we need to end our tests. There we go. Whoop, something is wrong. So let's say let test set of tests equals new. What does it say? What is wrong? It is animal tests, I believe. Yeah, it's because it's, there we go. It's because it's not this class. It's from the library that we have. So we need to define it. The library have something called test, and this is a set of tests. It's not a set of the class we're in, of course. And then this one will not be results, but just result. There we go. Our print result to string. TS run result. Two seconds. I'll just do it like this. I'm sorry. TSIO. I know. It's because it's the wrong one here. Right? No, it's not. Let's say what it says. It's not in scope. Okay, let's see what is wrong. Operation IO print said, I know what is wrong. It's because we have only imported our VDM unit. We have not imported our IO library. So I'll just take that one more time, just so you see what happened. I hit right click, new, add new library, both mark the VDM unit and the IO, and hit finish. There we go. Then we right click the unit test, because we need to define that test and execute should actually be called. So we'll go into run as, run configuration, make a run configuration with our VDM++. We will define this as our first unit test. And you could do that by hitting browse and then choosing the project you would like. And then we'll search for our tests here and our execute there. And it will fill in by itself, clean and easy. Close there, save, and run. Okay, what happened? We'll try there, run as VDM application. There we go, okay. And as we can see, test result, one was executed, no error, perfect. Okay, so we can actually test if the right thing happened. So what we expect now is that, let's say we +1 to this one, then it will no longer be the same we put in as we'll get when we get it back. So it will not be 15 anymore. So let's try to run it again. And as expected, one was executed, but one failed as before. And now, if we just go back, if we just go back, then here in our test construct, we can make a new one. We'll just make the same one to make it fast, but we'll say test get. And we copy that down here. And we here will say test get. There we go. We run it again. And as we can see, 2 was executed and 0 failed. So that is how you make unit tests. Maybe a bit confusing video, but if you have any questions or any recommendation of how to do this better, or if you think I need something in the video, then please comment it below or write it to me, and then I will try to make a new video if this one was not good enough. But thank you for looking. Check out the profile. I'll probably upload new video for VDMs as the project moves along. But thank you for looking. Bye bye.